Alright, this video will cover the first 4 pages of the final review, so we're going to go and get started. First question says, what is the domain of the following function? You have to remember that domain is talking about all possible inputs for your x values. So what x's can you plug in and still get something? And so if I look at this graph, I can see, all right, I can plug in -2 because -2 has somewhere to go. -1 has somewhere to go, and everywhere in between there is filled, like -1.5, for instance, would have someplace to go. So it looks like it goes from about -5 point something to about 1 point something, maybe like 1.8. But the key thing to remember here is that these x's go, or that, not the x's, but that this arrow means the graph goes on forever. So if I continue this graph, continue this line, imagining it keeping going down like that, and imagining it going down like this, is that eventually, if it goes on forever, 3 will have somewhere to go, 4 will have somewhere to go, 5 will have somewhere to go, and same thing over here. -6 has somewhere to go, -8 has somewhere to go, and so if it goes forever, every x from -infinity to infinity will be used. So all possible inputs, every number is a possible input, and you can get a possible get something back out. So all real numbers for that domain. On the flip side, the range is talking about all possible y values. So while your x's go from left to right, small to big from left to right, your range goes from low to high, so from bottom to top, for your y values. So this is all possible outputs. So again, I notice that these lines go down forever, so I know that if I imagine, let's say, -15 down here, -15 would be hit somewhere over here. Maybe it has the x value, I don't know, 20, 15, it doesn't matter, but at some point it gets hit. So that y value gets used. It would also get used over here somewhere. And again, if it kept on going down and down and down, every y value is going to go get hit below this thing. So the lowest value, kind of coming from that direction, would be -infinity. And then as I'm getting bigger, the y values go up. -8 gets hit, -7, -6, -5, -4, -3, up to the highest y value possible, which is -2. And I want to make sure I include -2. Bracket means I include that value. Parenthesis means I exclude that value. Because it's filled in, there's no open hole here, I want to include -2, so this should be -infinity up to -2 as my possible range, my possible y values. Okay. Next one, x and y intercepts. Your x-intercepts are where the single point, so you have to treat it like a point, which has a point, has an x and a y. So x-intercepts are where it hits the x-axis. So that's the point 4, 0. I'm sorry, 2, 0. And 8, 0. And your y-intercept is where it hits the y-axis, which is going to be 0, 6. The special thing about y-intercept is that the x is always 0. The special thing about x-intercepts is that the y is always 0. So x-intercept of zoom out here. So the x-intercept of 2, 0 and 8, 0, and the y-intercept is 0, 6. All right. Determine for what regions is the graph positive or negative. Positive is where your value, so it's positive values. And when it's talking about something about positive values, it's going to be talking about the y value. So positive y values and negative y values. So the positive y values are everything in this region here, so above the x-axis. And then negative would be in this region. So actually I need to do a little bit better job of shading here. So just in this part right here is where your values are negative. And anything over here or over here, your values would be positive. So if I break this up into regions, kind of like the points where your graph hits, there's 3 regions here. Imagine on my number line. So here's 3, and here's 7. If I'm in between 3 and 7 for my x values, so from 3 to 7 for the x values, my y values are negative. So this is this region right here. From 3 to 7, my values are negative. If I'm bigger than 7, like 7, 8, 9, or whatever, then my values are positive. They're above the x-axis. And if I'm below 3, anything to the left of 3, my values again are going to be positive. So if I pick like a point here, let's say if I imagine the point 2. 2 is somewhere over here. Maybe this has the point 2 comma 5 or something like that, or 4. But it's going to have a positive y value. The same thing if I pick any number bigger than 7, like 7.5. 7.5 is going to be right here. It's going to have a positive y value. Whereas if I pick anything in between 3 and 7, like 5, 5 would have a negative y value. So where is it positive? This is from negative infinity to 3. And from 7 to infinity, it's positive. And it's negative from 3 to 7. Notice how these are parentheses, because if you are at 3, you're on the x-axis, you're neither positive or negative. And the same thing at 7, you're neither positive or negative. So positive from negative infinity to 3, and 7 to infinity, and negative from 3 to 7, your answer should have been this one. What is the absolute maximum and absolute minimum of this graph? So because this thing goes up forever, there's no absolute maximum. Because there is a lowest point on this graph, there is an absolute minimum. It's right there. And so that point is somewhere in between 1.5 and 2. So maybe, who knows what, but let's say if we kind of judge it right there, it looks like somewhere between 1.5 and 2, and somewhere in between -6 and 7. So an absolute minimum, let's see, 1.8 and -6.4, that could be good. No absolute max, so it looks like it has to be this one. And again, the absolute minimum is a point, 1.8 for the x, -6.4, let's say, for the y. Didn't skip any, I don't think. How many relative maximums does this graph have? So relative maximum is this. I know it's relative means like in a location. And so if you zoom in on a location, could you tell what the maximum value is? So because this graph goes up forever, there's no absolute max. But if I'm looking in a particular region, like if I zoom in on, say, right here, this location, I can tell that right here there's a highest point. So wherever I see that kind of camel hump, right here, I can tell that that would be a maximum point. And the same thing is if I kind of was zooming in on this location, so from, say, 0 to, or maybe from like 1/2 to 1.5 or something like that, that there's a maximum right there relative to kind of everything else around it right now. So if you zoom in on these locations, if you can find basically a little hump that is going to tell you, say, like, okay, I can tell that that's the highest point. So that's the highest point. And the same thing over here. I can tell that this is also, when I'm zooming in, that that's also a highest point. So there's two relative maximums. If I zoom in on this area, that point's a maximum. And if I zoom in on this area and just kind of focus on that, that would be a maximum. So there's two relative maximums. Let's go on to this one. What regions is the graph increasing? So that's where your graph is going uphill as you read from left to right. So as I go from left to right, this is going downhill. And then right starting here, it starts going uphill, so that's increasing. And then it stops right there, starts going downhill. And then again, it starts going uphill. So this is again for what x values is the value, is your graph basically increasing, or the y value is getting bigger. So for what x's is the values increasing? And so that looks like from about negative maybe 1.8, so somewhere there to there. So that does look like maybe negative 1.8, maybe negative 1.9, up to about maybe, if this is 0.5, maybe 0.75. So from negative 1.8 to 0.75, so it looks like it'll probably have to be this one. And let's check this one. From about 1.8 and onward, it is going uphill. So that will be that. For what regions is the graph decreasing? So again, for what x values, as I read from left to right, is this graph decreasing? Well, as I read from left to right, it's decreasing up to there. Then it goes uphill. Then right here again, starting over, it's decreasing up to this point. Up there. So there's a region right here. From kind of here to here, it's decreasing. And from here on, it's decreasing. So from negative infinity to, if I kind of want to do a number line, that can help me out too, is I can do these like little inflection points where things change. So it changes directions. Let's say negative 0.6. So here's like negative 0.6. To the left of negative 0.6, I was decreasing. And then from 0.6 about to positive 0.6, I was increasing. So increasing from there. 0.6 to about 1.8, I'm decreasing. And from 1.8 on, for those x values, I am increasing. So the regions, say where I'm decreasing, are from negative infinity up to about negative 0.6. And then again from 0.6 to about 1.8. For those x values, the graph was going downhill. So that looks like B here. Last couple, put a check mark next to all the statements are true. The graph is increasing over the interval, so for these x values from negative 2 to 0. So if I just look from negative 2 to 0, so that is just highlighting this part of the graph. From negative 2 to 0, is this graph increasing? Is it going uphill? It is. As I read from left to right, it's going uphill. So that is true. It is increasing over that interval. The graph increases over the interval from negative 4 to negative 2. So this time, if I zoom in from negative 4 to negative 2, that graph is going downhill. It is decreasing. So that is not true. It does not get a check mark. The average rate of change, which is our slope, which we also think of as rise over run, from negative 5 to 1 is 0. So if I go from negative 5, so negative 5 starting here, and if I go to 1, that's here. So on average, as I went down and up, what is the average slope? What is the average rate of change? And so if I do my rise over run, to go from here to here, I rose 0 and I ran 1, 2, 3, 4, 5, 6. So that's a slope of 0. So on average, even though I went downhill and uphill, on average and kind of the aggregate, it's a change of 0. So my slope is 0. The graph is constant, which means it's kind of flat line over the interval -4 to 0. So -4 to 0 -4 to 0 is not constant. It's going downhill and then uphill. So it is not, doesn't have a constant graph. So that's not true. And then the average rate of change over the interval -4 to -2 is negative. So is that slope negative from -4 to -2? And because it's going downhill, yes, that rate of change will be negative. You're decreasing. So that is true. And then what is the average rate of change on the following intervals? So from rise over run. So from 0 to 2 is the first one. So the rise over run, I rose 1, 2, 3, 4. And I ran 2. So that's going to be a slope of 2. From 1 to 3 will be from here to here. And that rise and run, I ran 1, 2, and I ran the positive direction, so it's a positive run. And I rose from 1 to 9, so that's 8 altogether, because it went 1, 2, 3, 4, 5, 6, 7, 8. 8 over 2 is 4, so my speed's kind of increasing as I get bigger. And then from -2 to 2, so from -2 to 2, again, my average rate of change, I'm rising nothing and I am running, so that's going to be a slope of 0. Because if I try to do my rise over run, I rose nothing and I ran 1, 2, 3, 4, so it'd be 0 over 4, which is 0. Okay. And that is the first few pages about characteristics of graphs.